Up until now, we have discussed about linear inequalities and the different ways to solve them. So let's say we have an inequation 2x plus 3 is less than 7. Then we can solve it by first transposing 3 to the right hand side, and this is going to give us 7 minus 3. So 2x will be less than 4, and we are going to make the coefficient of x go to positive 1. To do that, all we have to do is divide both sides of the inequality with positive 2. Since we are dividing by a positive number, the sign of the inequality is not going to vary, so x is going to be less than 2. So this is going to be the solution of the original linear inequality, which is 2x plus 3 greater than 7. That means for all values of x less than 2, we will satisfy this particular linear inequality. For example, let's say if we consider x value to be equals to -1, then 2 times -1 plus 3, we're saying that this value must be less than 7. So let's check. We have 2 times -1, so that's -2. -2 plus 3 is positive 1. And it's a true statement that 1 is less than 7. Right. And let's say if we take a value of x which is not less than 2, but let's say we take x value equals to 3, a value which is greater than 2. So this is not going to satisfy the linear inequality. We can check that out by substituting x equals to 3 in a given linear inequality. So we have 2 multiplied to 3, so that's 6. 6 plus 3, so that's 9. So that means we're getting a value 9. And definitely 9 is not less than 7, that's greater than 7. So that means if we take a value of x which is greater than 2, then our inequality is not going to get satisfied. Now this is an algebraic way of finding the solution. So what we'll do today in today's session, we will discuss about equally interesting and I would say more intuitive way to find out the solution of a given linear inequality. So that will be using the help of graphs. So let's talk about it. For this, first we will be needing our Cartesian plane. So here we have our familiar Cartesian plane. So how to find out the solution to this given linear inequality? Okay, so let's do that. All we have to do is we'll consider the original linear inequality, but instead of the inequality sign, we're going to convert it to an equation. So let's say we have 2x plus 3. Instead of using the inequality sign, we're going to replace it with an equality sign. So we get 2x plus 3 equals to 7. Solving for x, we have 2x equals to 4, so x will be equals to 2. So here we have a value of x equals to 2. So all we have to do is draw a line whose equation is given by x equals to 2. So we know that any line for x equals to 2, the line is going to be represented by a line which is perpendicular to the x-axis. So this is going to be line x equals to 2. Now clearly we observe here that this is dividing the entire plane into two parts. So this is one of the region. So this is lying to the left of the line x equals to 2. And then we have another region which is lying to the right of the line x equals to 2. So this is going to be region number 1. The region number 1 lies to the left of the line x equals to 2. And we have the second region, region number 2, lying to the right of the line x equals to 2. How we have divided the Cartesian plane into two regions is going to be dependent on the line x equals to 2. So region number 1, we can have condition x. The values of x could be less than 2, or values of x could be less than or equals to 2. All we are doing is we're considering all the points on the plane which is lying to the left of the line x equals to 2, and we have two inequality. In one case we have x is less than 2, in the second case we have x is less than or equals to 2. The only difference here is that when we say x is less than 2, we're not considering the points that are lying on this particular line. So we're excluding the points on the line. We can say we are excluding the line. And if we say x is less than or equals to 2, then we have to consider all the points on the left side, which is region 1, including the points lying on the line as well. Now coming to region number 2, we're going to have two conditions. X could be greater than 2. So that means we are considering all the points lying to the right of the line x equals to 2, but we will not consider the points on the line. And if we say x is greater than or equals to 2, so this time we'll have to consider all the points lying on the line as well as all the points lying to the left of the line x equals to 2. So these are the case. So there are names for it. So when we say x is less than 2 or x is greater than 2, so in this case what we have is a open half space. So this is going to be referred to as an open half spaces. And for the second case, when we have x either less than or equals to 2 or x greater than or equals to 2, so in this particular case, we're going to get closed half spaces. Closed in the sense we are also including the points lying on the line. And when we exclude it, we are going to have open half spaces. So if we want to denote the region in set notation, then for region 1, we have to consider all the points x, y such that it meets the criterion that the values of x is going to be less than 2. This is one case. Or we have to consider all the points x and y such that x lies to the right of x equals to 2, including 2. And for region 2, we have two cases. We have the open half spaces. So here x is going to be greater than 2. And we also have to consider the closed half case where we have x, y, the points lying to the right of x equals to 2, and the points on the line are included as well. So we have x greater than or equals to 2. So let's try to understand this with the help of a few more examples. So here we need to find the solution to the linear inequality 2x plus 3y less than or equals to 6 graphically. So how do we approach this problem? So here first we'll consider our coordinate axis. What we'll do first, we'll have to consider 2x plus 3y equals to 6. We're going to consider a linear equation in two variables, x and y. And then we'll have to plot this equation graphically. So this is clearly a straight line. And to plot the straight line, or what we can do, we can use the x-intercept and the y-intercept. So first let's find out the x-intercept. To find out the x-intercept, what we'll do, we're going to suppose that y value equals to 0. So this is going to give us 2x equals to 6. So x will be equals to 3. And then we'll also find out the y-intercept. So to find out the y-intercept, all we have to do is we'll have to suppose that the x value is equals to 0 and then solve for the value of y. So we have 3y equals to 6. The y value equals to 2. Now, on the x-axis, we're going to find out the value x equals to 3. So we have 1, 2, 3. So this is going to be our x-intercept, which is 3, 0. And then we will also find out the y-intercept. So that's 1, 2. So this is the point 0, 2. So our straight line is going to pass through these 2 points. So we have the straight line. So this is our straight line, which is 2x plus 3y equals to 6. It has an x-intercept of 3 and a y-intercept of 2. So now that we have our straight line, so we can clearly see here that this straight line is dividing our Cartesian plane into 2 parts. So we have a region which is above it, and we have another region too which is below the line. So we have to find out the region. It could be the region 1 or it could be region 2. So we have to find out the solution to this particular linear inequality. So let's do that. So the simplest way to do is pick up a random point either from region 1 or region 2, and then we can substitute into this inequality and check if it is satisfying the given equation or not. To start with, what you can do, you can always pick the safe value. The safe value is going to be the origin, where we have 0, 0. So clearly this point 0, 0 is lying in the region number 2. So we will check whether if it satisfies the given inequality or not. So what we'll do, we will pick the origin 0, 0, and then we're going to substitute into a linear inequality. So we have 2 times 0 plus 3 times 0. So we have less than or equals to 6. So that's simply 0 is less than or equals to 6, and this is a true statement. Since it's a true statement, we can say that this point 0, 0 or the origin is satisfying the given linear inequality, and we will say that our solution is going to lie below this given line. That means it's going to be in region number 2. So all we have to do is we'll have to shade this region. So the simple way is draw some slanted lines. So this is going to tell us this is included. Now we will let these shaded lines, the slanted lines, touch the line. The reason we're letting it touch the line tells us that the points on the lines are also included. That's because here we have less than or equals to sign here. So we will have to consider the points, all the points in region number 2, including the points lying on the line. Now any points above above the line, so that means in the region number 1, are going to be discarded because that's not going to satisfy a given linear inequality. So this is a graphical way of saying the solution, a graphical way of finding the solution to the given linear inequality. So let's try to understand this with the help of one more example. So here we have to find the solution to the given linear inequality. 2x minus y is greater than or equals to 1. So what we'll do? First, we're going to consider the equation, so that we can easily draw a straight line represented by 2x minus 1 y equals to 1. To sketch this graph of the straight line 2x minus y equals to 1, we will find the x-intercept as well as the y-intercept. So to find out the x-intercept, we're going to let y equals to 0, and to find out the y-intercept, we're going to let x equals to 0. So letting y equals to 0, we're going to get 2x equals to 1, or x value will be equals to half. And letting x equals to 0, solving for y, we're going to get y equals to negative 1. So clearly, we can do it here. So let's say if this is 1, then this is going to be half. So half comma 0, that this is going to be the line. The line is going to pass through this particular point where the x-intercept is half. And it's also going to pass through the point 0 comma negative 1, which is going to give us the y-intercept. So we're going to draw a straight line that passes through these 2 points. So we have sketched the line 2x minus y equals to 1. Now that clearly divides the Cartesian plane into 2 regions. We have region number 1 and region number 2. Now we'll have to check what will be the solution. That means which particular region is going to satisfy the given linear inequality. For that, we will have to pick up points on the Cartesian plane, and the safe bet will be to choose the origin. So let's choose the origin. So once we choose the origin, then our inequality will be 2 times 0 minus 0 greater than or equals to 1. So we are getting 0 is greater than or equals to 1, but we know that this is not a true statement. 0 can never be greater than or equals to 1. So when we are getting a contradiction here, or we're getting a wrong statement, we can say that this origin point is not included. Since it is not included, we can reject region number 1. So if region number 1 is rejected, then automatically we will be selecting region number 2. So we'll be drawing slanted lines and make sure that the slanted line touches the line 2x minus y equals to 1, because we have a greater than or equals to sign present here. So that means all the points lying on the line must also be included. So this is going to be the solution, the graphical solution to the given linear inequality. And if we can find out any points lying on this shaded region, any random points that we pick up lying on this shaded region, this is definitely going to satisfy the given linear inequality. For instance, let me choose, let's say if we have here, let's say we choose the point 2 comma 0, and we'll see that this is definitely going to satisfy the given linear inequality. So we have 2 comma 0, which means we have 2 multiplied to 2 minus 0 greater than or equals to 1. So that's 4. 4 is definitely greater than 1. And if we choose a point lying on region number 1 other than 0, 0, so let's say we consider negative 2 comma 0. So if we substitute it here, so we have 2 times negative 2, so that's going to be negative 4. So negative 4 is coming out to be greater than or equals to 1, which is a wrong statement. So region 1, any point lying on region number 1 is not going to be a solution to the given linear inequality. Let's go to the next problem. In problem number 3, we have the inequality y is greater than or equals to negative 3. So to begin with, all we have to do is sketch the graph of the line y equals to negative 3. Now clearly, so this is going to be a straight line which is going to be parallel to the x-axis. So if you get confused, you can always use the slope-intercept form, which is given by y equals to mx plus c. So here, in this equation, we can see here that this is simply 0 times x. There is no x component here, so that means our slope is 0. Whenever the slope is 0, we know we have a straight line which is parallel to the x-axis. And also, this is going to pass through the point y equals to negative 3. So we are going to first consider y equals to negative 3. So this is the point negative 0 comma negative 3. And our straight line is going to pass through this particular point. So here also we see that our Cartesian plane is divided into 2 regions, a region which is above the line y equals to negative 3. So this is going to be our region number 1, and we have the region below y equals to -3, so that's going to be a region number 2. Now we'll have to find out in which region the solution is going to be. So we're going to choose the origin, and then we're going to substitute this back into our inequality. So we have 0 greater than or equals to -3. So this is a true statement. Since this is true, we will see that the origin 0, 0, that's part of the solution. So we will say all the region or all the points lying above the line that are going to be a part of the solution, and these slanted lines must also touch the straight line y equals to -3, because we have y greater than or equals to -3. Fine. So this solves the linear inequality y greater than -3. Now let's go to the next problem. So problem number 4, we need to find a solution to the linear inequality. Here we have an absolute value of x less than or equals to 3. Fine. So first we will do is we'll consider our coordinate axis. So what we'll do here, we will first consider the equation absolute value of x equals to 3, and we'll have to sketch the graph of this. Now immediately we get two cases here. The first case being it could be x equals to 3, or it could be -x equals to 3. Here we are going to use the definition that absolute value of x is defined as is going to take the value x if x is greater than 0 and its -x is x is less than 0. So fine. So over here, if we solve the second equation, rewrite the second equation, we're going to get x equals to -3. Now all we have to do is sketch two lines, which is given by x equals to 3 and x equals to -3. So first, let's sketch x equals to 3. So this is going to be a straight line that's going to pass through the point 3, 0. So this is our line x equals to 3. Similarly, we can sketch the line which is going to be x equals to -3. So that's a line, straight line, which passes through x equals to -3. We have the second line x equals to -3. Now here, this time, instead of having two regions, we have three regions. So we have region number 1. The region number 1 lies to the left of x equals to -3. Then we have the second region, which is lying between x equals to -3 and x equals to 3. And we're going to have one more region, the region number 3, which is lying to the right of the line x equals to 3. Now we have to find out the region or regions in which our solution is going to lie. So let's begin. So what we'll do? First, we'll have to choose the point 0, 0. So we'll choose the origin point 0, 0. So we'll substitute it here into our given inequality. We know that absolute value of 0, so that's always 0. So we have less than or equals to 3. So we have 0 less than or equals to 3. So this is a true statement. Since it's a true statement, we can say that the origin is a part of the solution. So since the origin 0, 0, that's a part of the solution, so we'll say that if we consider the first line x equals to -3, then our solution is going to lie to the right of the line x equals to -3. So it's all the it's also including region 3 as well. So this is our region. Now here we are letting the lines touching the line x equals to -3. So that's points lying on the line x equals to -3 is also a part of the solution. Then in the other case we have, since our origin is still included, we'll also have to consider that our region which is lying to the left of the line x equals to 3. So that is also a part of the solution. So this particular region, so it starts from the line x equals to 3 and goes to the left hand side. So all the points to the left hand side are also part of the solution. Now what we see an overlap of the two solutions because we have two inequalities. We have one x greater than -3, this is, and other one is x less than +3. So these are the two solutions. These are the two solutions we are getting, and to find out the common solution, we have to find out the region which overlaps both of them. When you clearly see, that's region number 2. So here we will see that our final solution is going to be region number 2. And how do we define region number 2? So that's the value of x. So we'll write it in the set notation form as all the points ordered pairs x, y, such that our value of x lies between -3 and +3. So this is the solution or solution set to a given linear inequality. Let us do one more problem that is going to help us understand this particular idea when we have an overlap of solution. This time we have the inequality absolute value of y minus x as less than or equals to 3. We have absolute value of y minus x less than or equals to 3. So what we'll have to do, we'll have to first consider the equation. We'll take absolute value of y minus x, so that this be equals to 3. Now this is going to give us two cases. The first case being we have positive of y minus x equals to 3. This is going to give us one equation, and we can even further rewrite this as x plus 3. So we are writing in the slope intercept form, where the slope of the line is 1 and we have a positive y-intercept. And the other, this is one case, and the other case is going to be negative of y minus x equals to 3. So we have y minus x equals to negative 3. So y will be equals to x minus 3, which means we have a positive slope but with a negative intercept. So let's try to plot the line, straight line. So here y equals to x plus 3. So we can use the x-intercept and the y-intercept to sketch the line. So we'll let x go to 0 such that y will be equals to 3, and when we let y equals to 0, then x will be equals to negative 3. So let's do that. So we have 0 comma positive 3. So this is going to be 1 point, 0 comma 3, and then we have negative 3 comma 0. So this is our straight line, y equals to x plus 3. So this is going to pass through these 2 points. So let's sketch it. So this is our straight line, y equals to x plus 3. Then next we are going to sketch the line y equals to x minus 3. For this, let's consider the x-intercept. So for the y-intercept first, so we'll let x equals to 0. That's going to help us find the y-intercept, which will be negative 3. Then we will consider y equals to 0, which is going to give us the x-intercept with a value positive 3. So when we have 0 comma negative 3, so this is going to be a point, 0 comma negative 3. This gives us the y-intercept. And we have positive 3 comma 0 giving us the x-intercept. So we have the straight line passing through these 2 points. So this is going to be our line y equals to x minus 3. Now they are parallel lines because both of them have a slope of 1. So whenever they have an equal slope, we can say that two lines are going to be parallel to each other. Also, we now have here 3 regions. One region is going to lie above the line y equals to x plus 3. The second region is going to lie between the two lines y equals to x plus 3 and y equals to x minus 3. And we have the region below y equals to x minus 3. So now we'll have to find out in which region our solution is going to lie. So what we will do is choose this particular point, which is the origin. So let's choose the origin value. So we have 0 comma 0. We'll substitute this into our inequality. So we have 0 minus 0, absolute value 0 minus 0 less than or equals to 3. So with this gives us 0 is less than or equals to 3, and we know that this is a true statement. So since it's a true statement, we can say the region 2 is going to be a common region or the common solution. Or what we can do, we can also separately solve each of the two inequality. So let's say if we start with y equals to x plus 3, so we can have the equation. We can have one set of linear inequality. So let's say we have, since we had y minus x less than or equals to 3, so this is going to give us one set of inequality, y minus x less than or equals to 3. And the second one, it could be, the second case could be y minus x could be greater than or equals to negative 3. So we can solve them separately. So for the first case, if we choose the point 0 comma 0, we'll see if the statement is true or not. So clearly we see that 0 is less than or equals to 3, so that's a true statement. And if we take the second inequality and consider the origin, then we have 0 greater than or equals to negative 3. So that's also a true statement. So we will say that for the first case, for the line y minus x equals to 3, so we say that its solution is going to lie below the line y equals to x plus 3. Right? So this is one solution. And then for the second inequality, we have y minus x greater than or equals to negative 3. So this is the line which corresponds to y minus x equals to negative 3. So since 0, 0, the origin is a part of the solution, so we'll have to consider the points lying above the blue line, which is given by y equals to x minus 3. And clearly we see that there's an overlap of solution, which is nothing but the region number 2. So we didn't have to go through that particular way. I just wanted to show you that this approach is also correct. So here we have already said that 0 is less than or equals to 3. So that means it's the overlap of solution, which is region number 2. So region number 2 is the solution to our given linear inequality. So let's do one final problem. So this time we'll have to find a solution to the linear inequality absolute value of x minus y is greater than or equals to 1. So we'll break it down in the form of an equation. So we have absolute value of x minus y. So this is going to be equals to 1. So immediately we get two keys. The first one being x minus y equals to 1. And the other case being negative of x minus y equals to 1. We have x minus y equals to negative 1. We will get two equations of straight line. For this straight line, we'll first find out the x-intercept, which will be by letting y equals to 0. So we will get x value equals to 1. And when we let x equals to 0, then y value is going to be equals to negative 1. For the second case, if we let x equals to 0, then y will be positive 1. And if we let y equals to 0, then x will be negative 1. So let's sketch the two lines. So we'll first sketch this line, x minus y equals to 1. So we have y equals to 0 and x equals to 1. So 1 comma 0, this is going to be one point through which the line is going to pass, and the other point is going to be x equals to 0 and y going to be negative 1. So this is the other point, 0 comma negative 1. So here we have the straight line x minus y equals to positive 1. Next, we were going to sketch the line x minus y equals to negative 1. So for x equals to 0, we have y value equals to positive 1. So this is going to be the y-intercept, and the x-intercept will be for y equals to 0, x is negative 1. So this is going to be the x-intercept, negative 1 comma 0. So we'll sketch the straight line that passes through these 2 points. So we have a second line as well. So we have x minus y equals to negative 1. We also have three regions. Region 1, which is above the line x minus y equals to negative 1. We have region 2 between the two lines, and region 3 below the line x minus y equals to positive 1. So we will consider the origin. So when we choose the origin value, which is 0 comma 0, then our inequation becomes absolute value of 0 minus 0 greater than or equals to 1. Solving this gives us 0 is greater than 1, but that's not a true statement. That's an incorrect statement, which tells us that region 2 is not a part of the solution. So we are going to reject region number 2. So let's take a point from region number 1. So let's say we have to consider a point. We have negative 1 comma 0. So let's take a point negative 2 comma 0. Clearly this is lying on region number 2. So from region number 1, we're selecting the point negative 2 comma 0. So we'll substitute this into an inequality. So this is going to give us negative 2 minus 0 greater than or equals to 1. So we have absolute value of negative 2, and that value is always positive 2. So we have positive 2 greater than or equals to 1. This is a true statement. So that means we have region 1 is a part of the solution. Then we are going to come to region number 3. So we'll choose a point which is lying in region number 3. So let's choose this particular point, which is 0 comma negative 2. So we'll substitute in this inequality. So from region number 3, we're selecting 0 comma negative 2. So here we have 0, absolute value of 0, minus of minus 2, so that's positive 2 greater than or equals to 1, and this is also giving us a true statement. So we can say the region number 3 is also a part of the solution. So here we have the solution, which is region number 1 and region number 3. So that means we'll finally say that the solution to the linear inequality absolute value of x minus y greater than or equals to 1 has two solutions. So one of the solution will be we'll consider the ordered pair x comma y such that we have x minus y. Since it is lying above it, so we're going to say less than or equals to negative 1. This is one solution, and the other one will be all the ordered pair x comma y such that we'll consider the second equation, which is x minus y equals to 1. So we have x minus y greater than or equals to 1. So this is the solution set.